NASA announces Starship Flight 5 launch date. A new era beyond the FAA. Introduction. NASA has officially announced the launch date for SpaceX's Starship Flight 5, marking an exciting turning point in space exploration. After a long journey of development, rigorous testing, and overcoming regulatory hurdles with the Federal Aviation Administration, FAA, the fifth flight of Starship is set to push humanity's reach beyond Earth's orbit. As the most ambitious spacecraft designed to date, Starship represents the future of space travel. This announcement also signals a new era for NASA and SpaceX, where the focus moves from overcoming delays to achieving historic milestones that will shape the future of human exploration on the Moon, Mars, and beyond. The FAA and regulatory challenges. Overcoming obstacles. The Starship program, while revolutionary, has faced extensive regulatory scrutiny. Since the early flights, the FAA has enforced detailed environmental and safety reviews, with every test launch subject to meticulous examination. These requirements, while essential for public safety and environmental protection, have posed a series of challenges for SpaceX. Each test flight and development phase demanded a level of transparency and accountability unique to aerospace engineering, slowing down the program but ensuring that every safety measure was considered. Now, with FAA approval for Flight 5 secured, the path is clear for Starship's most ambitious test flight yet. Farewell to regulatory delays. This era is about proof of concept and paving the way for humanity's future beyond Earth's orbit. Starship Flight 5 is poised to meet these challenges head-on, promising to demonstrate the technical advancements that have set SpaceX apart as the leader in reusable rocket technology. What is Starship? The engineering marvel behind SpaceX's vision. The Starship rocket is unlike anything that has come before it. Designed as a fully reusable spacecraft, Starship consists of two main stages, the Super Heavy booster and the Starship upper stage. Standing at a towering 120 meters, it is the tallest rocket ever built and, when paired with SpaceX's cutting-edge Raptor engines, it boasts unprecedented thrust capabilities. The vision behind Starship is ambitious. A spacecraft capable of carrying large payloads and human crews for interplanetary travel. While traditional spacecraft are typically single-use, the Starship system is designed to be reusable, which could dramatically reduce the costs of space exploration and transportation. With the Super Heavy booster returning to Earth after each launch for refurbishment, Starship represents a paradigm shift in space travel economics, setting the stage for an era in which humanity can explore beyond Earth affordably and sustainably. NASA and SpaceX, a strategic partnership for the future of exploration. NASA's partnership with SpaceX has already transformed the landscape of space exploration, starting with the Commercial Crew Program, which successfully allowed private companies to transport astronauts to the International Space Station, ISS. NASA has relied on SpaceX for some of its most critical missions. Starship represents the next evolution of this collaboration, and NASA has contracted it for future Artemis missions, specifically as a lunar lander for crewed moon missions. NASA's long-term vision with the Artemis program aims to establish a sustainable human presence on the Moon as a foundation for future Mars exploration. Starship size, cargo capacity, and reusability make it the ideal vessel for ferrying astronauts and large amounts of equipment to the Moon, helping NASA achieve its ambitious goals. With Starship Flight 5, NASA and SpaceX will gather crucial data and insights to verify the spacecraft's viability for lunar missions, including structural integrity, precision landing, and fuel efficiency. Technical innovations and goals of Starship Flight 5. Each Starship test flight has presented opportunities for improvements, and Flight 5 is no exception. SpaceX has made significant upgrades, particularly to the Raptor engines, thermal shielding, and reentry systems, all aimed at increasing the spacecraft's reliability and efficiency. Raptor 2 engines, a step forward in propulsion. The Flight 5 launch will feature SpaceX's upgraded Raptor 2 engines. These engines, designed for increased power and durability, are crucial for Starship's long-haul missions. With higher thrust-to-weight ratios, Raptor 2 is optimized for space travel, and this launch will provide essential data on their performance during extended flight durations. Enhanced Thermal Protection System, TPS. Returning to Earth from space requires that Starship endure extreme atmospheric reentry conditions. SpaceX has upgraded the spacecraft's thermal protection system to ensure its heat shield can withstand temperatures of over 1,650 degrees Celsius, 3,000 degrees Fahrenheit. Flight 5 will test the integrity of these heat shields, which are a critical component for future reusability and interplanetary missions. Reentry and precision landing. Starship's distinctive belly flop maneuver is designed to maximize its surface area, creating aerodynamic drag and reducing descent speed. This flight will test Starship's ability to perform a controlled landing with precise alignment, validating its potential for safe, repeatable returns for both cargo and crew. In-flight telemetry and data collection. Flight 5 is expected to generate an unprecedented amount of telemetry, collecting data on atmospheric pressure, temperature, velocity, and structural stress. This data is invaluable for refining Starship's design and optimizing its systems for long-duration missions. The implications of a successful Flight 5. A successful Flight 5 could pave the way for more advanced missions, including preparations for NASA's Artemis program and potential Mars exploration within the next decade. If Starship proves capable of reliable reentry and controlled landing, it will be a monumental step toward the realization of a fully reusable spacecraft capable of interplanetary travel. The implications extend beyond NASA's lunar objectives. SpaceX's vision of making space travel affordable and accessible could become reality, as Starship's reusability promises to lower the cost per launch and mission significantly. By proving the spacecraft's reliability and efficiency, Flight 5 could enable a future where private companies and even other countries can access deep space at an unprecedented scale. Public enthusiasm and the global response. The announcement of Starship Flight 5's launch date has generated global excitement, with space enthusiasts and scientists eagerly anticipating this major test. Public interest in space travel has surged in recent years, and Starship's potential to make human space exploration accessible to a wider audience has captured imaginations worldwide. News of the launch has dominated social media and sparked discussions among scientists, journalists, and space enthusiasts alike. Live-streamed coverage of the launch will likely attract millions of viewers, providing a front-row seat to this historic event. Many anticipate that Flight 5's success could set a new benchmark for space exploration, sparking renewed interest in human spaceflight and inspiring a new generation of space explorers. Challenges ahead. Preparing for deep space missions. Despite Starship's progress, significant challenges remain. For Starship to fulfill its role in NASA's Artemis program and beyond, SpaceX must demonstrate a high degree of reliability and safety across multiple test flights. The challenges of long-duration missions, orbital refueling, and radiation shielding for crewed space travel to Mars present additional technical hurdles. Moreover, Starship's success hinges on perfecting the reusability of both the Super Heavy booster and the Starship spacecraft, a feat that will require continued development and innovation. SpaceX's competition with other companies like Blue Origin and international agencies, such as the European Space Agency, ESA, adds urgency to the program. As global interest in space grows, Starship's success could cement SpaceX as the leading innovator in the field. However, this competition could also drive advancements across the industry, pushing companies and agencies to invest in more ambitious missions and technology. The future of space exploration. A new era beyond the FAA. With the launch date of Starship Flight 5 confirmed, NASA and SpaceX are stepping into a new era of space exploration. This mission represents more than just a test flight. It's a statement about the future of humanity in space. By overcoming the obstacles of FAA delays, Flight 5 signifies a transition from regulation and testing to execution and achievement. Looking beyond the FAA and regulatory constraints, SpaceX's vision for a multi-planetary civilization is closer to reality. With NASA's Artemis program aiming to establish a sustainable presence on the Moon, Starship's success could lead to the infrastructure necessary for long-term human habitation on other planets. A successful Starship program would mean reliable cargo transport, potential lunar bases, and, eventually, the first crewed missions to Mars. Conclusion. NASA's announcement of the Starship Flight 5 launch date represents a transformative moment in space exploration. With FAA regulatory hurdles finally behind them, NASA and SpaceX are ready to embark on a mission that will shape the future of space travel. Flight 5 will test Starship's upgraded engines, thermal protection, and reusability, gathering critical data for the next steps in lunar exploration and Mars missions. As the countdown begins, Starship Flight 5 is not just a test of technology, but a demonstration of human ambition and innovation. It's a leap forward for NASA, SpaceX, and the global space community, signaling the start of a new era beyond regulatory delays and toward a future where humanity can explore the cosmos sustainably and affordably. With Flight 5, SpaceX is taking a crucial step toward making the dream of interplanetary civilization a reality, proving that the boundaries of space exploration are only as limited as our drive to push them.